Welcome, everyone. Along with NSF Director, Dr. Sethuraman Panchanathan, it's my pleasure to welcome you all to this year's NSF and NSB Awards ceremony. Once a year, the National Science Foundation brings together top leaders in government, industry, and science to honor dedicated and remarkable people and their extraordinary contributions to our country. In 2021, we're once again navigating around the COVID-19 pandemic. I regret we can't be together in person to celebrate and honor our award winners, but I'm thankful that we can use technology to gather a larger circle of friends and family from around the world to help our winners celebrate in real time. At this event, we get to celebrate new knowledge and discovery across diverse science and engineering disciplines, celebrate the next generation of scientific talent, and the understanding of the widespread benefits from science and technology advancements. With the presentation of NSB's Vannevar Bush Award, we'll recognize an individual for his extraordinary leadership, public service, and contributions to our nation through activities in science and technology. With the NSB Public Service Award, we'll honor two individuals who have contributed to public understanding of science and engineering in the United States. And I'd like to offer a special thanks to Maureen Condick, Chair of the Board's Honorary Awards Subcommittee, for leading our board in the selection of this year's winners of these two awards. With the presentation of NSF's Alan T. Waterman Awards, we'll honor two young scientists and recognize them for their exceptional achievements and promise for significant future impact in their fields. To celebrate the recipients, we're premiering two videos that highlight the winners' science and public service work. The first video will showcase the winners of the National Science Board Awards, and the second will be about the Alan T. Waterman Award winners. After the video presentation, we're featuring a special panel discussion with these amazing thought leaders, led by a former Waterman Award winner, Dr. Jennifer Dionne. And a special thanks to Allison Gillespie of the board office and NSF's Denise Zanino for bringing these videos to life. The Vannevar Bush Award honors lifelong leaders who have made exceptional contributions toward the welfare of humankind and the nation through public service activities in science, technology, and public policy. The National Science Board established this award in 1980 in memory of Vannevar Bush. He served as science advisor to President Franklin Roosevelt during World War II, helped establish federal funding for science and engineering as a national priority during peacetime, and was behind the creation of the National Science Foundation. This year's winner, Ralph Gomory, is being recognized for a long record of mathematical, scientific, and technologically enabled achievements, and for work he did while an executive at IBM and as the leader of the Alfred P. Sloan Foundation. His career spans decades, beginning in the 1950s when he helped the US Navy solve some of its most challenging resource management needs, and continuing all the way into the early 2000s when he led philanthropic efforts to solve some of our toughest societal and educational problems. The National Science Board Public Service Award honors individuals and groups that have made substantial contributions to increase public understanding of science and engineering in the United States. This is increasingly essential as scientific and technological advances permeate our daily lives. And this year we have two awardees in this category. Bill Hammack is a researcher and science communicator who uses theatrical skill and an artistic approach to video production to explain the wonders of engineering to the general public in plain language. William Jackson is being honored tonight as both a chemist and an advocate. His contributions to the field of laser chemistry helped improve our understanding of the universe and brought forth many new discoveries with ground and satellite telescopes. He's also an exceptional mentor and one of the founders of the National Organization for the Professional Advancement of Black Chemists and Chemical Engineers, an organization which has helped to increase participation of minority students in the sciences since 1973. Before our video begins, I'd like to remind everyone that these special showcase videos will be available on the NSB and NSF YouTube channels and websites. And now to the video.
I think African-American scientists need for success the same thing that all scientists need for success: a burning interest in what they're doing and the passion to work at it day and night. And to do that, you must really want to be a scientist. I grew up in segregated Birmingham, Alabama. My father was a high school teacher who had finished Tuskegee Institute, and he taught algebra and auto mechanics. My mother worked for the federal government. I wanted to be a scientist when I was about 12 years old. I was reading an article about Percy Julian, who was really my role model. He was also the first African American who was a member of the National Academy of Sciences. I think my upbringing was a catalyst because I was taught whatever you do it well and try to help other people get ahead. So it was not just the racism that I encountered, but it was a racism that I knew other people encountered too. I finished my PhD in the early 60s. And when I went to American Chemical Society meetings, I saw only one African American. NSB, or the National Organization for Black Chemists and Chemical Engineers, was started in the early 70s. What we conceived of at that time was to have an organization that we could address what we saw as the problems of getting more African Americans in STEM, to provide scholarships for undergraduate and fellowships for graduate students by leveraging our participation in government, industry, and universities. It still provides a pathway for people seeing other people who have been successful. It still, at the local level, generates more interest, science in the K through 12. My goal in astrochemistry is to study the reactions that explain our observations of comets and in planetary atmospheres. I'm working with a graduate student on a NASA grant to provide information about one of the molecules that we see in comets. I'm glad that the NSB chapter got reactivated. I am pleased that there is now a NSB chapter on this campus. It is open to all students of all races who agree to the principles of NSB, which is that we are dedicated to increasing the diversity and numbers of minorities in the STEM fields. The organization continues to grow and continues to open up its leadership to younger people going forward. They bring new energy and new ideas. The themes may be the same, but the methods will change with time.
It's important for the public to understand science and engineering so that they can be good citizens, so they can make choices. And I think by creating these videos, by talking about what engineering is, what it can do, maybe even what its limits are, that you help people make those choices. I think what I do is a fusion of an inheritance, if you will, from both parents. My mother was a botanist, but it was really her power of explanation that's the thing that I retained. The way that you open up a world to somebody that they haven't seen before. And then my father was a theater professor. I often went to rehearsals as a kid and watched him work. But what I really learned from him was craft. I wanted to reach out to the public. I wanted to explain engineering to them. And when I looked around, I talked to the University of Illinois, and they said they would create a position where I could come here, and in whatever way I wanted, I could reach out to the public.
So at the low end of the market, the VHS machines were cheaper than Sony's Betamax.
And I started in public radio. I did several hundred pieces for public radio. How to think about engineering, about how it affects your world. They were really an extended definition of what an engineer is, what an engineer does. And it really honed my storytelling. The very first book I wrote was a small book called Why Engineers Need to Grow a Long Tail. And the second book was 8 Amazing Engineering Objects. When writing a book, we always think of a most general reader, somebody who is curious, and we try to bring them along to understand more science and the deeper engineering subjects. I run the channel Engineer Guy Video. It has a little over 1 million subscribers and some 60 or 70 million views now.
The engineering in this, a modern disposable diaper, stuns me.
And in it, we just discuss the things that interest me and fascinate me.
The ingenious design of the aluminum beverage can.
The microwave oven, how it works.
This microwave oven is a truly remarkable feat of engineering.
Plastic injection molding, how they make all the plastic things that surround you. The Engineer Guy videos are shot in this room. This is my studio. I usually create the videos with students. Over the course of doing the videos, I actually became more appreciative of engineering. You want to make a contribution to the world, and I think these videos do that. I suppose, though, at the very root, I just enjoy creating them. I enjoy thinking about how you're going to explain something. I enjoy the challenge of it. So there's an aesthetic aspect to it that I enjoy greatly, and it drives me.
I'm Bill Hammack, the Engineer Guy.
Science is more and more a part of our everyday life. When I was growing up, science was not. Science is actually happening around you. It has an impact. You can't take that distant view of it anymore. H.G. Wells, when I was a boy, he had a big effect on my life. I was at camp, so I must have been around 10 or 11, and I read a book by H.G. Wells about a future world in which intelligent robots took care of making everything, and the people didn't have to work all day. And I thought, gee, that's a great idea. You know, it'd be like being in camp all year round. And when I finally met a computer, then I realized this is it. And that's basically why I joined IBM, because they had the thing that H.G. Wells was talking about, and I wanted to be a part of it. I joined the Navy because I didn't want to do theoretical math that only a few people could understand. The Navy did give me a chance to do really applied mathematics, and they didn't have anybody but me, as far as I can tell, who had a PhD in mathematics. It was just a life-changing experience. I started to work and learn about OR, operations research, and the techniques that are used in that. It was really just thinking mathematically about practical problems, and the world is full of them. And they had some Navy problems which they didn't know how to solve. I invented a method to solve them. But it turned out that method, which is called integer programming, has all sorts of other applications and became a very big thing. And they said, look, we've got mathematical ways to design a task force. It's a group of ships. It might be an aircraft carrier and a couple of destroyers, maybe a cruiser. What ships should go together with the right range and the right guns and the right aircraft? But the trouble is, using linear programming, the ships often come out fractional. And I said, it's about getting integer versus whole number solutions to linear programs. And they said, that's impossible. And that's why when I found a way to do it, it made a big splash. And suddenly, I was well known. I wanted to go out where there were computers, which I felt were the wave of the future. And there'd be problems they wanted to solve. And so IBM's research division, which was just being set up, seemed like the obvious place to go.
In research, we work both on IBM products and on scientific understanding.
When I became the head of IBM research, we were going to contribute to science and to IBM, because by contributing to science and being part of the world of science, that's how you get good people. A good one was the scanning tunneling microscope. A couple of our guys in our Zurich lab got the idea for making a totally new kind of microscope because we needed to know where the atoms on the surface of silicon were. It worked for silicon and it worked for everything else. And it ended up actually winning the Nobel Prize for Physics. I've always been an applied person. I've always wanted to solve problems in the real world. I want to have an effect.
Well, thank you. That was incredibly inspiring. And I know that everybody out there is joining me in congratulations and applause for Ralph Gomory, Bill Hammack, and William Jackson. I'd now like to welcome Dr. Panchanathan to present this year's two Alan T. Waterman Awards.
Thank you, Madam Chair. It's truly a pleasure. I also would like to join in congratulating Bill Jackson, Bill Hammack, and Ralph Gomory for this amazing achievement and what they have contributed to science, technology, and engineering for several decades. We are so proud of you, and we are very grateful to you for all your contributions. And it's truly an honor to be with you today to celebrate this wonderful achievement of yours. The Alan T. Waterman Award, which is also a huge achievement at a very young stage in the careers of scientists and engineers, was created by Congress in 1975 to mark the National Science Foundation's 25th anniversary and to honor the agency's first and longest serving director, Alan Tower Waterman. Under Waterman's 12 years of guidance, the newly formed NSF established its role as the preeminent source of support and investments for researchers who are forging new paths at the frontiers of science. Over 70 years later, I'm proud to say that this remains our core mission. In honor of Alan Waterman's commitment to supporting foundational research and the scientists behind groundbreaking discoveries, we give this prestigious award in his name. The Waterman Award is the highest honor the National Science Foundation bestows on early career scientists and engineers and recognizes outstanding researchers 40 years of age and younger, or not more than 10 years beyond receiving their PhD awards. And this is an award that is along with this recognition, which is a grant of $1 million over 5 years for scientific research or advanced study in any field of science or engineering. Each year, an external panel of distinguished scientists and engineers carefully review and evaluate an impressive pool of nominations. These nominees are some of the brightest and the most talented researchers our country has to offer. With the tremendous talent I know is embedded in our nation's STEM institutions, selecting a winner is no small task. That is why I would like to first recognize the Waterman Award Committee members for their hard work. I want to thank every member of the committee for your yeoman service, your time, your efforts, and a special thanks to the chair of the 2021 committee, Maria Claway. It was truly a pleasure interacting with them and knowing how hard they worked and how diligently they chose the winners from a very, very, very prestigious pool of nominees. I also want to thank Keith Swerder, Stephanie Hill, and Kimberly Albuquerque in the Office of Integrative Activities. Together, they worked to coordinate the awards process within NSF this year, and their work in support of these awards is appreciated. For only the 5th time in 45 years, NSF has given this award. We are fortunate to have 2 honorees. They are both innovators who are creatively addressing some of the most challenging scientific questions in their respective fields. It is now my distinct honor and pleasure to recognize the winners of the 2021 Alan T. Waterman Award, Dr. Nicholas Carnes and Dr. Melanie Mashad Wood. Professor Carnes is the Creed C. Black Associate Professor of Public Policy and Political Science at Duke University. Dr. Carnes' groundbreaking research examines how a range of societal institutions influence opportunity and inequality in the United States. His research has delved deeply into how a person's social background may influence their decision to pursue public service and what focus would increase their opportunities to serve. Melanie Mashad Wood, Professor Wood, is a professor of mathematics at Harvard University and a Radcliffe alumni professor at the Radcliffe Institute for Advanced Study. Dr. Wood's pioneering research has provided new insights into some of the oldest and the most difficult problems in mathematics. She studies number theory, working on centuries-old mysteries about patterns in prime numbers and the statistical behavior of how factorization works in different systems of numbers. There is no doubt that Dr. Carnes and Dr. Wood exemplify the exceptional qualities that the Waterman Award seeks to recognize. The work that they are doing continues to push the boundaries of research and discovery, changing the way we think about the world around us and creating a lasting impact that will no doubt lead to a bolder, brighter future. Congratulations to both Dr. Carnes and Dr. Wood. I look forward to following your exciting and important work.
My research tries to understand what the obstacles are that can discourage middle and working class people from getting involved in public service. One of my first role models in my education was my mom. When I was in elementary school, she was raising me by herself, and she always really stressed the importance of reading and education. In terms of my interest in the social sciences, one of my most important early influences was my high school forensics coach and English teacher, Ms. Kathy Smith. She really pushed me to realize I had potential I didn't even know I had. What first inspired me to study how to create more opportunities for people to engage in civic life was, hearing kind of in graduate school, if you want to be a politician, you have to be really rich or you have to be an attorney. And that got me thinking, is that really true? Or is it possible that, public service could be accessible to a broader range of Americans? If we want to understand how to create more opportunities for people to engage in civic life, we actually have to understand a broad range of social processes. We have to understand the factors that, make it easier for some people to take time off work, or to, commit time to public service. Getting involved in public service is a really time-consuming and really complicated process. The challenge for scientists is understanding all the links in the chain, understanding all the places where this process can be made more accessible to middle and working class Americans. Why is it important for people to get involved in public service? The answer is, decisions that affect entire communities, you really want everyone who's affected to have a voice in the process. It matters who has a seat at the table. It matters whose voice is heard. And when we have a more open, more inclusive public service process, we're less likely to have blind spots. We're less likely to make mistakes. We're less likely to rush to judgment when, everyone's voices are heard in the process. When I heard that I was a recipient of the Waterman Award, my first thought was, that they must have called the wrong person. But, one of my top priorities for the $1 Million Award is learning more about how we can create opportunities for middle and working class people to be involved in public service by learning from other electoral democracies around the world. What leaders can do. My proudest professional accomplishments are the students I've worked with over the years, especially through Duke's program for students from first-generation college students or students from lower-income families. For a university to really succeed at its teaching and research missions, it has to be accessible to students regardless of the background they come from. My wife and I are foster parents through the Department of Social Services in Orange County, North Carolina. And, I sort of think of my research, my teaching, and sort of the work I do in my personal life as really connected. The overarching goal is to create opportunities and help people sort of flourish and reach their full potential. And so a lot of the work I do today is influenced by some of my early experiences doing jobs, as a cashier, as a receptionist, as a construction worker. Those experiences really showed me just how many wonderful, intelligent, hardworking people there are in middle and working class jobs all over the country right now who, would make great civic leaders who would be fantastic public servants.
I study number theory, so things like the prime numbers, numbers that can't be factored into numbers smaller than themselves. Primes are like the atoms, the fundamental building blocks of all of the numbers. And I study how those primes can combine, where primes occur, how different combinations of primes can come to be. When I was in middle school, I started doing math competitions, and one thing I really liked was that they would ask me to do questions that I hadn't been taught how to do. And so I just had to use what I knew and come up with a new idea. And that was the first thing that really hooked me on mathematics. People have been trying to understand prime numbers, their patterns and mysteries for literally thousands of years. They're one of the most ancient mysteries of mathematics, and yet for all of their ancient natural beauty, they're also the foundation of our modern lives. Every time you buy something online and send your credit card number or log into your bank, anytime anyone needs to rely on sending secure information over the internet, we rely on that information being encrypted. All modern encryption schemes rely on the properties of prime numbers, and so even if you don't know it, you're using prime numbers constantly every day. One of the important ideas that I use in my research is the idea of a moduli space. A moduli space is like a space of possibilities, of all the numerical or the geometric things that could be. You could think about it like if you imagine collecting a bunch of data and then you graph a whole bunch of data points. And that plot of the data points, the cloud of data points, it itself will have some shape, some geometry. Maybe it arcs one way or it comes down another way, and that tells you something about the problem that you've been investigating. And by understanding the geometry of that space of possibilities, we can learn more about number systems and numbers themselves. I hope that this award and my work can draw more attention to fundamental mathematics. We don't know what technology is going to be the most important in 20 years, in 50 years, but we can know that it is going to be built upon the foundations of mathematics. Throughout my career, there have been a lot of challenges of being a woman in mathematics. I have had to be over and over the only girl in the room or the only woman in the room, and it's often hard. But I've been so grateful to have a network of great women colleagues, friends, mentors in mathematics, and the support that I have gotten from them has been crucial for my career. For me, part of the beauty of mathematics is its universality. Questions about the numbers, the whole numbers, 1, 2, 3, 4, 5, they're ancient. They draw the attention of thinkers from every culture around the world. To me, I feel like questions about numbers like this are one of the most fundamental aspects of our universe, of what's out there. So I find beauty in the way that mathematics tells us about the most basic language of the world, the language of numbers.
Sorry, I was muted by somebody. So congratulations again. Thank you so much. I really appreciate the tremendous work that you're doing, and we're so proud of you. Know that this is something that on an annual basis, I was part of the National Science Board, and Dr. Ochoa has been there also for several years now. We used to hold it in the State Department's unbelievable place. I mean, it's just Franklin Roosevelt's room. And then I think 1 year or 2 years we had in the International Justice of Peace gallery. I mean, it was just awesome. And so what you're missing is that ambience of a tremendous place where we all get together, and you don't get to wear this, you wear a black tie, and it's a very different kind of an environment, very celebratory. And that's what we miss is the last two iterations. The first one that we had last May, we had to postpone, hoping that we would be able to do it face-to-face. And we ended up finally giving up because of the unfortunate situation that we have been in for the last year. So we hosted it along with the last December meeting, where again, we tried the Zoom format, and it worked really well, despite the fact that as I was saying, we missed the celebration in person, but it was really, really good. And then we had a panel that was moderated by Vint Cerf, who used to be a National Science Board member. Some of you may know Vint. We call him one of the founders of the internet, fathers of the internet, and sometimes he's referred to. So he moderated the panel the last time, and it came out really well, to the extent that people felt really comfortable this time around that we can still go ahead and not postpone and have this virtual format, notwithstanding the challenge that we're facing now, that we could still do it in the virtual format and make it really good. So that's why we are pursuing this format, and it is awesome to see all of you on the Zoom screen. But hopefully someday, when we all get together in person, that you will still all be able to make it, face to face, and we will definitely love to shake your hands and so on. Ellen, what do you think? Your reflections?
Yeah, absolutely. in some way, I mean, I miss seeing everybody in person, but I have really, really enjoyed the opportunity to get to know our award winners through the videos as well. But I know that probably a year from now, next May, when we next do the awards, that we'll have the opportunity to once again get together. And that also gave us the opportunity to pull in a variety of people across the government, as you know, that come to the ceremony and see that. But I hope some of them are also watching with us tonight.
The video is queued in, so it's ready to go. But I'll tell you one thing. Now, somebody told me, because I came in as director last July, never had a face-to-face gathering other than a few people that I've met. And somebody told me, Panch, I don't know whether you're 5 foot tall or 6 foot tall. I don't know. So that's what people are still intrigued by, how people look. And so that was very funny when I heard that. So now over to the video of Dr. Melanie Matchett-Wood. We're excited to see that now.
Hello, my name is Jen Dionne, and I'm pleased to host tonight's roundtable discussion with the 2021 National Science Board and National Science Foundation Award winners. I'm joining you from the campus of Stanford University, where I'm a professor of material science and engineering and the Senior Associate Vice Provost for Shared Facilities. The pandemic may have limited our ability to gather in person, but it by no means diminishes the importance of the awards that are presented, nor our ability to celebrate and virtually honor these incredible individuals. Tonight, we meet for a roundtable discussion with our winners, all of whom are thought leaders and STEM innovators. We'll give these pioneering minds a chance to talk with us and to each other about their research. We'll also hear their thoughts about the challenges and the opportunities facing the science and engineering enterprise in the United States and the world. Let's begin. William Hammack, I'd love to start with you. You've devoted your career to communicating science to the public. What messages do you think are most important for scientists and engineers to convey? And what are the most effective means or the media to communicate those messages?
Well, I've always wanted to see engineers and I guess scientists who added to their technical acumen with a broader view and understanding of the world, and in whom creative problem solving reigns supreme. So that's one of my main hopes, the things that I want to show. I want to show engineers are creative. Engineering is its best. When it's at its best, it's invisible. We don't think about our furnaces. We don't think about the details of an airplane or the principles, underlying a microwave oven. And it's only when it fails that we take notice. So part of my goal is to lift that curtain, to reveal the invisible, and to highlight that the suppleness of the mind that creates that material world that's around us. So I think I'd like to emphasize the creativity parts, show people that it's creative.
Yeah, that's neat. What do you think are the most effective media to communicate that creative side of science?
Well, the term nowadays, or it used to be new media or social media. If you're under 35, you call it media. But what I think that new reminds us of is that we now have the means of production and the means of distribution, which as engineers and scientists, we didn't. And so we can create very cheaply, and we can deliver it to an audience for whom it is tailored. So we can build an audience around the world and don't have to worry about the same issues that, PBS or Discovery had to, say, 25 or 30 years ago. So I'm a big believer in using social media to do it. I've done both radio and television, and they're wonderful media to work in. Radio is a very intellectual medium because it's all words. And I left it before the podcasting started, but might return to that someday. But I really like video because we can demonstrate and show things to people.
I really agree with you enormously about the creative aspect of engineering. It's often so underestimated. To make something actually work and work on a large scale, people think that just kind of happens once the ideas are there. Not so. You have to solve all kinds of things on the way. And that is not appreciated, how much invention is in everything that we use.
I like the idea of emphasizing creativity in science and engineering. Actually, when I'm evaluating science and engineering, that is the principal mark of a great scientist or engineer, creativity. The problem with most students is that when they are taking science, is they look at science and engineering and mathematics as things they have to memorize, a whole bunch of facts they have to memorize. And when in fact, what they should be trying to do is to understand and make correlations and then let their own mind work to think about what they may do in the future.
I completely agree.
Yeah, I agree. Melanie, I don't know if you wanted to chime in on that. I know in your video you mentioned that something that brought you to math was participating in these competitions where you got questions that you'd never been faced with before and you had to try to come up with answers.
Yes. You know, as a mathematician, when you talk about wanting to communicate the creativity that's part of the engineering process, I think that, you know, that's what I want to help communicate for mathematics as well. Too often, I think students learn mathematics in a way where it's a series of rules that you have to follow, where what we really need is people who can think mathematically and use mathematical modes of thought to solve problems that we don't yet have a list of rules for how to answer. You know, those are all the interesting problems. All the hard problems are the ones where we don't yet have that list of rules, and we need to find it, and we need to use the tools we have and combine them or change some of them. You know, that's what I want to see out of mathematically educated students is a mode of thinking where we can figure out how to combine those rules, to use them in a new way, to apply them to a different situation. And that is entirely a creative process. And in some sense, the tools you learn, like solving an equation, those are like the artist's paintbrush. They're tools you need to do the creative process, but they're not the paintbrush isn't the art. I think the same holds true for a lot of, across mathematics and science and engineering.
Yeah, what an awesome analogy with, the tools that we learn in school being like the paintbrush, but we want to empower students to be able to make the beautiful, canvas or the beautiful painting. Ralph, I'd like to turn to you, in part because you picked up on this idea of creativity. You've held so many positions throughout your career, spanning academia while you were at Princeton, the Navy, when you were director at IBM, and then president of the Sloan Foundation. Based on those diverse experiences, how do you think we can best build a strong scientific and technical workforce that simultaneously uses creativity in their thought process?
And I hope I can say this in a way that's coherent, all right? I think we are neglecting the power, the thinking power of the ordinary person, all right? Before the Industrial Revolution, right? People lived on farms, right? If you've ever worked on a farm, and I have, okay, they knew how to do all kinds of stuff, right? But they were not taught that in a classroom. They learned by imitating other people, one-on-one, right? That was the way everybody learned for 10,000 years, right? After the Agricultural Revolution, right? And today, we don't do that anymore, right? We take people, when we stick them in a classroom, okay? And then the teacher tells them what they're supposed to remember. That's not the way human beings are built to learn. Now, some people are good at this classroom thing, and we weed the others out, all right? And it's only these folks who go on. But those other people are great learners. They have 10,000 years behind them, but they didn't adjust to this artificial new way, all right? What we have to do is alter our teaching, and technology will allow this, so that people can be taught the old way, understanding, seeing what happens, imitating others, right? And we will suddenly find that all these people we're discarding really can do everything, right?
Well, Ralph, I have been an engineering professor for now over 30 years, and I have to say, I agree with you. I find it odd, in some ways, the way in which we teach. When I think of how, as a human being, I fix something in my home, if the faucet is leaky or dripping, I certainly don't take 4 months to read about fluid dynamics and the production of drips and the way metal is formed. I do it in a just-in-time way. And I work my way backwards to figure out why that faucet is dripping and how to fix it. And this is true of just anything I have. I mean, I have 2 small children, age 3 and 6. And so for the pandemic, I bought a bubble machine and had never thought about bubble solution, and, worked my way backwards from how do you make bubble solution? What is the best way? And learned about that. And so in a way, the classroom experience and the curriculum doesn't mimic how we typically learn as humans, which I think is what you were alluding to.
Yes, it's exactly that. And because these people don't do well in this funny situation that we invented, we sort of shuffle them aside. I say, let's stop shuffling them aside.
Well, I was going to say that I have not seen a strong correlation between grade point and your success as a practicing engineer. There's a threshold. There certainly is a threshold, but it's just enough. And I think that also relates to your point.
What you say really resonates with my experiences as an educator with students, because the situations where I see students take off is when they have a project or a problem that they want to solve.
Yeah.
Not that, they're necessarily assigned, not just a homework problem, but something that they're interested in when they're doing their own research. The speed at which they can learn new tools and new ideas when they have a goal, like, I want to learn this tool so I can use this to do that. It's like 10 times faster. Oh, yeah. And they learn it more deeply, and it becomes, they become more fluent in it than if they just learn it from, reading a book or taking a regular class. Yes. If they're motivated by a use for that, and they already have inside of them, that drive. So I think, that is absolutely what I see working with students, which is that they can learn something much harder than you would have thought they could have ever learned in a class if they have within themselves a reason they want to use it for something that's important to them.
Yeah, I was very lucky that in an early stage of my education, I went to a weird school where mostly we did projects, okay? And that awakened in me an enthusiasm for solving things, which all the subsequent schooling failed, though it tried hard to distinguish. Right? And so this is the natural way. We have to find ways to deliver things that way.
Yeah, Ralph, I totally agree. And I wonder if William Jackson wanted to jump in because, Will, you did a lot of incredible work establishing NOBUSHE, which has led to a cadre of successful, diverse global leaders in STEM. Can you maybe piggyback a bit on what Ralph was saying in kind of the best way to learn science and how you reached out to diverse budding STEM scholars and turned them into leaders?
I was one of 5 people who started NOBUSHE. It was not just me, and we came from it with different points of view. At the time, I was at Goddard Space Flight Center when we were starting it. two of the other people were at colleges and universities. And the fourth person was in industry. He was an engineer who had left MIT and started his own company. The Nobuche started with the idea of what we wanted was to bring people together who were interested in furthering more African Americans in science. We didn't define it so narrowly that you had to have degrees, you had to be an academic. All you had to do was to be interested in that point of view. You had to have a belief that African Americans could do science first. And so that was one of the things that we all believed in. My interaction with students is sort of is based a lot on what has already been said. When I meet a new student in graduate school, or I'm teaching, even in undergraduate school, I tell them, find what you're interested in. I don't care what it is. It's a passion. It's something that you get up every morning, and that is what you are interested in. And throughout your life, it's going to carry you through all the difficulties you may find. I can't judge who's going to be successful. I look back over all of the students I've been involved with, and I'm always surprised who becomes that great star. The ones that I think are going to be that great star, most of the time don't become the great star. What that tells me is that we don't really know who is going to be the most creative person. It's just like art in that respect. That creativity is something we have not been able to measure. Just like we can't measure intelligence, we can't measure creativity.
Yeah, thanks, William. When you mentioned it's been hard for you to tell who's going to be a good student versus who's going to be a great one, one of my mentors once said that the difference between a good researcher and a great one is just 6 months. And it's a matter of how you train them in those 6 months for how great they'll become. Yeah, a lot of what we're hearing, are kind of the ingredients to be successful citizens of the world. You need to have passion. You need to be given the right tools. And William, I like how you said you can't judge. Nick, I wanted to turn to you. How can we instill these skills in the public, especially lower and middle class citizens, to help them better engage in politics or public service?
Thanks. I think there's a lot of sort of interesting overlaps between the discussion we've been having and how I think about public service. So how someone goes on to become a leader in their community or a political leader, an office holder. Ralph started us by talking about how sort of an overly rigid conception of what an education is, ultimately leads to bad outcomes. It leads us to sort of prevent individuals from flourishing and reaching their potential. And collectively, it means we lose out on the, good work they would have produced. And I think of sort of public service and civic life in similar ways. If we have an overly rigid way of thinking about, what a politician should look like or what a local civic leader should look like, if we require people to check certain boxes, in some level, we may be doing more harm than good. We may be losing out on sort of perspectives that we would otherwise find really beneficial, that would really help a community flourish. And so I think there's a kind of harmony between this conversation about thinking more broadly about education and the work I do thinking more broadly about how to create opportunities for people to get involved in public service. And they kind of look like the way we've been talking about education. I don't think anyone would say if you wanted to train the next generation of phenomenal public servants, you would stick them in a classroom, and make them to listen to some political scientist lectures. I mean, that might be useful for some things, for like our conversation, than maybe like a traditional college course on civics and politics. And I think going forward, if we want to create more opportunities for middle and working class Americans to get into politics, it's going to look a lot like our conversation about how to bring out people's creativity and people's insights in, STEM or in engineering.
I really agree with that. And I also would like to add that although it's hard to predict who will make the great discoveries, you can look at the people who make the great discoveries and see if they have something in common. Now, I've known quite a few of these people, and I've made quite a few discoveries myself. And I would say they and these people think about this stuff day and night, okay? Liking what you do is one of the ways in which it becomes possible to put in much more thought than the average person, okay? And every one of the people I know has that property. They are willing to think about it and think about it and think about it. And then what was hard for others becomes automatic for them. And then something happens.
It reminds me of a quote from one of my favorite athletes, Michael Jordan, who said, "I have failed over and over again, and that is why I succeed." If you keep practicing, keep thinking about it, I think that's and not giving up. That's the key ingredient for success. Nick, I do want to go back to you. I understand that you received NSF support as a graduate student. How is it that NSF support and your training as a graduate student influenced your subsequent career?
Sure. So, William, you mentioned that, sometimes we can't predict who's going to go on to be. I was really thinking, I don't know that many people would have looked at me early on and said, like, this guy's going to really succeed as a social scientist. I ran into a lot of challenges early in my career. And one of those was sort of that there weren't many people studying the topic I was interested in, and there wasn't sort of a scientific infrastructure there. There weren't sort of data sets. There weren't even kind of best practices for research design in some respects. There weren't professional communities or conference panels I could go to. And so my program of research was really kind of, I had people say, don't go down this path because there's going to be a really high startup cost. In 2009, I got an NSF dissertation improvement grant, and that was truly like my big break as a researcher. It let me collect data that had never really existed before, test my hypotheses with kind of a rigor that would satisfy scholars in my field. But it was also helpful as a kind of signal that the research I was doing had potential. And so it helped, I think, convince other people. And truthfully, it helped convince me that the path I was on was one that was worth going down. So yeah, it was immensely personally meaningful to me to receive this Waterman Award, in part because it's not an exaggeration to say my entire program of research that I work on today wouldn't have been possible without the NSF support back when I was in graduate school.
That's great. And Melanie, I wanted to call on you next. Could you tell us a little bit more about your research in prime numbers? And if we think about math as kind of a universal language, it's something that everyone understands, like, what sort of analogies can you make between language and your studies of prime numbers and factorization?
Well, I love the way of thinking of math as a universal language, especially because it's the language of the universe. It's the language in which we can express how the universe and how everything works. I mean, we're seeing that in every science, even sciences that 20 years ago weren't expressed in the language of math. Now they're learning things through big data, through mathematics and statistics. So I think it's the universal language, absolutely, because it's the language of the universe. But when we think about a language, we think about, like, our language that we know that as adults, we basically know the language. Maybe every once in a while you come across a new word, but you basically know the language. The difference with mathematics is that it's as a society, as a people, it's like we're still young children learning the language, because even though we know some of it and that we know has been remarkably useful, there's so much more out there that we don't know than what we do. And what we've learned, like young children learning a language, what we've learned so far has been really useful. So we are naturally driven to try to understand more. So I research questions about prime numbers, how numbers factor, and how the underlying systems of numbers that underpin the language of mathematics work. And what we know about them so far, for example, already it underpins our modern life, because it allows us to do cryptography and to securely send information over the internet. But we don't know what we're gonna need in 20 years and 30 years as technologies change. We don't know what mathematical tools, what kind of numerical structures we're gonna need. And so, part of what I research is trying to understand what mathematical systems are out there, what kinds of ways numbers can be broken down in different systems and how they work. So we have that language for the next, technology, or the technology that we're going to have 20 years from now or 50 years from now.
Nick, I wanted to ask you, how do you influence certain communities? And as I think, looking back over my life, that one of the most effective ways of working with communities was to listen to the community. Too often, we go into a community and we say, well, this is what you need to be better. And I think that's a wrong way to do it, because first, you don't know the community. And you need to go in with an open mind, respect the people in the community, and then you will be able to cooperate with them to make it a better community.
My research really starts from a position that I think aligns with, the concern you raise, which is, we don't want people from outside telling a community. The goal here is to bring people from the communities affected by public policy, affected by, the political process, bring them into the political process, bring them to the table, because, to the larger point, like when we exclude people from important decisions, we're losing their perspectives. We're creating, blind spots. The best decisions come when you look at a problem from every possible angle, and that means you have to bring people different from yourself, and especially people who are from the communities being affected. They have to be there. It can't be an afterthought. It can't be someone trying to speak for a community that isn't a part of it. So that's ultimately, I think that's kind of the heart of the research I do, or sort of the starting point for a lot of the work I do on how we make public service accessible to people who currently it's not, or there are barriers.
Nick, I want to jump off of that and post a question to anyone on the chat who wants to answer. What challenges do you think we still face in building a diverse, equitable, and inclusive STEM community? And how do we overcome them? And I think your research has kind of given us clues as to how we might overcome these, but I'd love to hear everyone's thoughts.
I think there was a really good point before in our discussion about how too often scientific education is rather different from the process of doing science. If the education is about, learning a list of facts, about, having the right answer to every question, and the process of of doing science, as we've discussed, is about creativity. It's about actually most of the time having the wrong answer, but then being able to learn from how you were wrong and improve and, bring in new ideas and eventually get somewhere. And so I think that frankly, that the perception that one gets of science from learning about it as a list of facts to be memorized is a barrier that keeps people out of science, because who would want to do that? I didn't want to be a mathematician when I was young and thought mathematics was about solving problems that you had been taught how to solve. What got me passionate about mathematics was when I learned that it was about solving problems that you hadn't been taught how to solve. That seemed much cooler and much more fun to me. And I think most scientists, that's how they think about science. But we need to communicate that to young people, and that needs to be part of math and science education.
I think this is so true, and I want to bring the floor back to William Hammack, who of course has his Engineer Guy YouTube videos with millions of followers. William, could you tell us a bit more about how we kind of convey this, passion for science and what it can enable to our public?
Well, this is probably just a very personal answer, but I choose things that fascinate me. I'm not that smart a guy, and so when I look at things, like, I don't know how that works, and spend time figuring out how it works, or more importantly, have people working with me that that help to figure out, so that comes across naturally. I think in the presentation, as somebody once said, this is the most fascinating thing to him until the next video, and I think that's largely true. So I get that my own personal passion for what is exciting and what is interesting to me about that object. But we also are very conscious of thinking about our audience and thinking about what we call an entry point to it, because we're on YouTube. We're looking to somebody who doesn't necessarily know a lot of science, and we try to figure out what it is that they might understand and backfill with the information. I will say that our videos, rough drafts or kind of storyboard versions, go to about 2,000 people who have signed up and help us fill in those gaps. All right. And that's a new media thing. It's so cheap to make those and distribute those that let's send it to 2,000 people, and about 100 get back to you, and you find out what it is they don't understand, or you also get an expert who tells you what you don't understand, which is useful also. And so the other end of it is we can't tell everything in a video, so we look to be sure that somebody who's watched the video will have what we call a well-formed question when they're done. So we may not have answered that, but the way they ask the question will lead them through Google, through asking somebody else, through a book, to a correct answer. And so that well-formed question, I think, is an important part of how we abridge the videos and how we communicate, what's there.
Yeah, that's a great way of putting it. It's more about how you inspire new questions than answer existing ones. Another question for the award winners, thinking about the science and engineering enterprise, especially in the United States, what is a hope that you have for where we might be in 2030?
Wow. I hope we will not be where we are now. In the 70s, 4% of the math and physical scientists were native born or African Americans. Now, 5 with PhDs. Now 5% are African Americans with PhDs. So over the last 50 years, we've increased the number by 25%. African Americans represent roughly 13% of the population. You would think we would have done much better than that. We can do much better. And what I see is the same problems associated with African Americans reoccurring over and over in history. when the slaves were first freed, we had a great boom in education. We had more people being educated. Schools were being built. In fact, the public schools in the South were built during Reconstruction because that's what African Americans, former slaves, wanted done. And they did it for everyone. So we have to realize that, and I don't think this is something we've realized, there are forces against the integration of society, the equalization of the American dream. There are people who are committed to not doing that. So we have to be eternally vigilant about doing that.
Yeah, Nick, I think this is a great segue, especially since you, are both a scientist and social scientist. What piece of advice would you give to someone starting out or wanting to pursue a career in science and or public policy?
Well, so I think, first of all, creating opportunities, that's really important. That's what we're talking about here. Putting resources in place so that people have access. But then I think beyond that, we know people, they really plug in not just when the resources are in place, but when there's someone on the other side bringing them in, recruiting them, encouraging them, telling them this place is not, this place is for you. And so a lot of the students I work with are first generation college students, are students from lower income families. And the message I send them about the social sciences, and I think this applies, more broadly, is we need you. So I think it's easy if you come from a family where college wasn't the norm. It's easy to feel like this isn't for me. This place isn't for me. I don't belong here, or my background is a liability. I need to, change the way I dress, change the way I talk, so that people won't catch on that I'm not sort of from this world. And so the message I want students who feel that way to hear is, no, it's just the opposite. Your background isn't a liability, it's an asset, because it gives you a perspective on problems that people who don't share your background won't necessarily have. And it's going to allow you to ask questions and to propose solutions that wouldn't occur to somebody who doesn't have your experiences. And so that's the message I think I would have for someone who is just starting out, who looks at the collective endeavor of social science, or universities or science more broadly, and says, I don't see a place for myself. I want you to know that probably means you're more necessary than you could possibly know, or you're more important, you're more valuable than you'll realize until you get started.
Such an amazing perspective. Yeah, Melanie, I want to give you a chance to answer this question too, especially since you mentioned you were often the only woman in the room doing math. What advice do you have for budding STEM scholars, particularly those who are underrepresented?
Yeah, that's a great question. And I also just really want to underline what Nick said about how much we need the variety of perspectives and the broad range of ideas and people from different backgrounds in science and math. The questions that we have to answer, the problems, the scientific and technological problems that we need to work on, they're hard. And they're not going to be answered by doing the same thing people have done before. And so we need different perspectives, and we also need combinations of perspectives. It's usually not just one idea or one perspective, but several different ones that get put together in different ways that really produce the next breakthroughs. So I really want to, I really just want to underline how great that point is in what a need there is, and what a motivation that should be for all of us for investment in scientific and mathematical education that can bring everybody to the table. You know, more personally, to someone who is looking to get into science, especially from underrepresented group, I think it is really important to find some network, you know, when you're of people that you can relate to or like you in the ways that maybe you feel like everyone around you is not, that you know, those kinds of networks have been crucial for me in getting over the bumps in the road.
Well, it seems to me that you're echoing what evolution has said, right? The way you get through when you hit a problem and you're stuck, you go to the guy next door, all right? And those networks used to be there in a different world. We need to recreate them, and we can, right? We don't have to do things in the fixed and rigid way. How about networks of people who are helpers, right? And you know how to get in touch with them. And maybe there are 2 or 3 of them that you talk with all the time. We can do all these things now.
Thank you all so much. I completely resonate with what you're saying about convergence being the engine for innovation. And I think it echoes some of the words of Vannevar Bush, who over 75 years ago laid the foundation for what is now the National Science Foundation. He said, science is most effective when as a member of a team. And I think we need to make that team as inclusive and diverse as possible. And with that, I think science can help ensure our health, our prosperity, and our security as a nation and as a modern world. So with that, I'd like to raise a glass and give a toast to all of you and to science, the endless frontier. Congratulations to each of you on your remarkable achievements, and thank you so much for spending the time with us tonight. Cheers.
Cheers.
Thank you so much, Jennifer. It's truly a pleasure, and it was an awesome panel. More importantly, we are very proud of you, having received our own award and then now chairing the panel and moderating it so wonderfully. It was awesome. Thank you so much for that.
Well, thank you, Punch, and congratulations to the Waterman winners, Nick Carnes and Melanie Matchett-Wood. And I wanted to join Jennifer Dionne in raising a glass to our awardees. And I hope people are sort of at least virtually joining me in doing that. And I wanted to thank everybody watching for your patience as we work through some glitches. And what I hope you'll remember is the accomplishments of these amazing people and the inspiration they provide. And again, if you want to watch the videos about our winners again, I think starting tomorrow, you'll be able to visit our website or return back to this YouTube channel to see them. So from everyone at the National Science Foundation and the National Science Board, and especially Panch and me, congratulations to all 5 of our award winners. A special thank you to our discussion moderator and former Waterman Award winner, Jennifer Dionne, for her participation in tonight's event. And thank you all for tuning into this special ceremony and awards panel. And for board members, the board meeting is adjourned for the day.
Thank you.
That was a fantastic evening. Thank you so much to all of you.